Hello, everybody. I'm going to give you the directions for the electrolysis lab today. Now, electrolysis is the splitting of the water molecule. So in class, you're going to split the water molecule. You're going to use electricity, and you're going to break the bonds of H2O and end up with some H. Actually, H2 is the gas, hydrogen, and O2 is the oxygen you breathe in the air right now. You're going to end up with two separate test tubes, with each with a different gas. They're going to do this lab 3 times and compare and see which one is most efficient, which one does it fastest. So I want to really briefly go over for you the materials you're going to need. Your source of electricity is going to be a 9-volt battery. This is going to be clipped onto a wire. This wire has 2 ends. One end is going to be attached to a metal bit of foil. We're going to call this our electrode, and it's going to go inside of a test tube. Then that's going to go inside the container of water. Now, water on its own doesn't conduct electricity very well. So this water has something inside it. It has I'm going to get all that air out of there. So it's just full of water. It has in it a electrolyte, and you're going to do it 3 times because you use 3 different electrolytes. You're going to use first salts, second baking soda, and third hydrochloric acid. So the other end of the wires get connected now to our battery source. You want to be careful when you do this that the alligator clip isn't at an angle so that the metal's touching the other clip there. It's going to short out. We don't want the electricity, the current, to go right from one post into the other part of the battery. We want it to go through the wires and make a complete circuit that way. The final stage of your setup is simply you're going to take your test tubes and tilt them upright. Now, it might be helpful to have a rubber band or something to do this. You're going to tilt them up. I'm just going to lean them in the corners here. What's really important is that you're leaving them upside down, and now they're full of water. Like I said, you may want to have some tape or a rubber band to hold them upright, but the current is now flowing through our water. There's just a weak voltage and weak amount of amperage, but this current is going through the water because of the electrolyte, and it's slowly making a little thin stream of bubbles, which is going up inside each test tube. And then those bubbles are slowly going to fill up each test tube with just a separate gas. Now from class, you remember that I said, remember, we told you, remember the word panic. Just a trick to remember that the first part of the word starts with P and A. The positive part of this circuit here is we call the anode. And you can actually read off here's a separate battery, read off the battery which side is positive and then which side is negative. But the positive side will be the anode, and attracted to the anode will be the oxygen. The oxygen is a negative ion. It's going to get attracted to that positive electrical lead that post the we called it the electrode, and therefore in this case it's the red wire. In the other side then will be the cathode, and the word panic ends with the C part. NIC, the negative part is the cathode. That'll be collecting the I think I said that wrong. It's the hydrogen. So the result here is we're going to have 2 test tubes with different amounts of gases. Whatever you collect for oxygen, we should find that we have twice as much hydrogen. Actually, that's how they discovered 100 years ago the formula H2O, that there are 2 hydrogen for every oxygen. And you should see that same experimental result in your glass test tubes. So when you're done with this, what you're going to do is record, first of all, how long it took. Let's say I did this and it took me 15 minutes, and I stopped before the first test tube is completely full. So I want to make sure that I can measure how much gas was made. And if it gets completely full, then the bubbles start leaking out of the test tube and just going up in the air. Things have gone too long. So we'll say 15 minutes, it's pretty close to the bottom. On one of them, and the larger one, the one with the bigger bubble of air, should be actually full of I said that wrong. Yeah, hydrogen. So then I want to, at that point, mark on my test tube exactly where the bubble level is. So I keep it upside down, and it's gas, 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 water. Right where the water line is, I'm going to mark that off with a grease pencil. And then I'm going to do the same with the other. What I'm going to do next is test to see which gas it is. super fun. You're going to take a flaming wooden match or a little bit of a splinter from a wooden popsicle stick, and you're going to, for the one you know to be hydrogen, the one that has the larger amount of gas, you're going to have that upside down in the water. At the last minute, right as you take it out, you have the match lit already, or the flaming splint. And then as that water comes out and you expose that hydrogen, which can float away, it's lighter than air, like helium, you're going to have the match right at the end of the test tube. And if that's hydrogen, what we would expect is it will combust, it'll explode, and you'll hear a little as it really quickly shoots out of the test tube. It might sound like a penny whistle or some sort of strange instrument. It might just pop, and you might hear, like, the classic thing they say in the textbooks is it's going to bark. You're going to just confirm that was in fact the hydrogen. The other one, the oxygen, will be a little different. Since you know it's the one with less gas, and probably you can guess that's the oxygen, if it worked like we said it would, you're going to take that burning match or a burning splint of a popsicle stick, let it burn for 30 seconds, get kind of hot, and then blow it out. And really quickly, while it's still glowing red, like a coal from a fire you just put out, like a little ember on the end of that stick, pull the test tube out and stick that in what should be a pure oxygen environment. And it, with 100% oxygen, should glow brighter. It'll give off more light, and the little glowing ember part will look bigger. It might even burst back into flame. It might even reignite. So you're going to confirm those. But what you really want to do is, now you've marked off the level in the test tube. How much gas did you make? You're going to then go get a graduated cylinder and fill this with water. So you have it right up to the water line, and pour it into the graduated cylinder so you can read the number and see how much gas you have. So now you know, let's say the first time you do the experiment, you're doing salt, NaCl, sodium chloride. You know how much H2O, how much hydrogen you made, how much oxygen you made. You're going to record it. So you want to make sure that you know which electrolyte it is and how many minutes it took, hopefully 15. But if it's a strange number like 7.5, just write that down. We'll tell you how to do that math in class. You're going to write down the amount of each gas that you got, how much hydrogen, how much oxygen. And then you're going to calculate the rate. If you got 2 grams of oxygen, or let's say hydrogen, 2 grams, 2 milliliters of hydrogen, and it took 15 minutes, you could probably get 4 times that if you let that clock run for a full hour, right? 15 minutes is a quarter of an hour. So instead of 2 grams in an hour, you might make 2 times 4 is 8 milliliters of gas. So you're going to figure out what it would be for a full hour. If, for example, you had 15 minutes, a quarter of an hour, multiply the amount of gas you made times 4, and that would be your rate. That amount of gas, in my example, 8 milliliters per hour. And that's the data you're going to collect. Okay. Now you're going to also write a conclusion and complete this as a full lab. But first, you need to make a graph. So, excuse me, I want to show you how to do that. We're looking for some basic things that we want to see in every graph. So let's say that this y-axis is your rate. By that, we mean how fast you made the gas, what speed you made. So your volume of gas per hour. Those are your units. And on the y-axis, sorry, the x-axis going across, we want to know your type, the type of electrolyte. So the first one, let's say it's going to be all I have room for. The first one might be sodium chloride. I'm going to write NaCl. You later would do your baking soda, NaHC3, and then you're going to do hydrochloric acid also, all in the same graph. Hydrochloric acid is abbreviated HCl. Hydrogen is H and Cl is chlorine. And for each one, you're going to have a number. You've calculated the rate now. So you'll have here listed your units. And I don't know what that's going to be here. So I'm going to say this is 1, 2, let's say 1, 2, 3, 4. Here's 5 milliliters per hour, 6, 7, 8, 9, 10 milliliters per hour, and so et cetera. Well, 13, 14, 15. You might have gotten, let's say, a rate of, for your hydrogen, 12 milliliters per hour. And for your oxygen, you might have only 6. They might not be exactly twice as much hydrogen, half as much oxygen, but they might be close. So I think I can squeeze in one more here on my graph. I'm going to then say that next is my sodium. There you go, baking soda, just got it in there. And let's say that it looks a little bit different. You can put these all on the same graph, and there would be my oxygen. Oh, I did that too high. Let's say right there. And then you could do a bar graph for your third experiment, the hydrochloric acid. When you're done, you're going to write a conclusion, and you're going to talk about whether or not the data supported your hypothesis. And therefore, you're going to answer the question, which is the most efficient, which is the best way to do electrolysis. And then you're going to talk about what kind of errors did you have? What kind of things could you do better? Just like any experiment. But mostly we're going to let you do something powerful, like break the water molecule, and see how we might do that. For example, if we go try and live on Mars and have to create our own water supply, with our water supply, create our own oxygen to breathe. And then we have this leftover hydrogen, which we can use for batteries and as a fuel for vehicles, etc., to make heat. So this is going to be an important part of our semester as we move forward and talk about living on Mars. Enjoy the lab today, work hard, go through the procedure step by step, and hopefully this video will help.